Bismillahirrahmanirrahim. Very good afternoon from my side. Welcome to part 2 our recurrent neural networks and long short term memory. So today we will discuss about the architecture of LSTM and some code. So today's agenda, first of all, I would like to talk about the introduction and then why LSTM over RNN, mm, and then vanishing gradient and exploding gradient descent problem. After that, LSTM architecture and overview. Later on, simple RNN code on Vertex AI. And finally, we will show how apply LSTM in a uh, stock price data set. Uh, let's start with first of all, in our traditional consider we have only two model that I already told in last week. Consider we have only two model, artificial neural network and CNN. We all know that CNN is dedicated for images, and artificial neural network it works with fixed size data input. So whenever in terms of variable length data, so we cannot perform well by ANN. So then we can use RNN, and RNN itself has some disadvantage. Before that, we know that in RNN it also need sequential data. We all know what does mean by sequential data. Uh, just for remind, there are a lot of example about of sequential data like stock market price prediction graph, or any voice of audio, or any video. And we know that a video is collection of clip. So if the sequence is not ordered, or if the sequence is broke, we will not get the final result, or we cannot understand actually what does it mean. So why need LSTM over NN? Well, so though RNN developed for handling sequence data, and we know that everything has some advantage and disadvantage. When the data length going to be longer, then it cannot perform well RNN. Sometimes it occurs two problem. Uh, One is vanishing gradient problem, another is exploding gradient problem. So what is vanishing gradient problem? Well, so let's look about the theory. What does it say? During backpropagation, we know that uh, by with help of gradient descent, we optimize the loss. So during the backpropagation, gradient descent going to be smaller and smaller. Eventually, it like nearly zero. So the it cannot update the actual weight basically. So uh, the changes of weight very negligible. So the model cannot perform well. For example, let's assume that three friends that are called A, B, C. So suddenly A missed the class, B and C presented. So C want to update with the class task. So he asked A that let let him to know what does the class task. C directly did not share anything with the sorry, A didn't directly share anything with the C. Instead of, he shared 70% of knowledge with B, and B have 70% knowledge of A. He also shared 70% knowledge with C. So uh, actually C can know only 49%. I will show the pictorial one later. uh, and another one is exploding gradient problem. So in the vanishing gradient problem, that occurs the uh, vanish the weight actually, that never update. And on the other hand, exploding gradient problem, it occurs the like weight goes to higher one. Our goal, primary goal, is to reduce the weight, adjust the model, where we can see that our weights, we know that weights to connecting between two connecting node weight, so path weight, so it's going to large and large. So that's why model predict unstable result. And if we look at this, the curve, we can see that when the vanishing gradient occur, it reach almost zero. And when the exploding gradient descent, it never goes to the optimal minima. Beyond it, weight increases. So now talk about LSTM. Uh, Already you know that the LSTM means long short-term memory, and it's the extended version of RNN. And in the LSTM, basically it helps to reduce these two major issue. One is vanishing, and another is exploding gradient problem. So if you look at this, excuse me, look at the picture, that the vanilla RNN and the LSTM picture, and it's look like quite complex than vanilla RNN. We will also deep dive discuss about it. So architecture of LSTM. Here I just consider one as one unit, and we know that in RNN or LSTM is also RNN, so it's a sequential, like a connection of same cell again and again. So I just pick one cell here. So if you look at my cursor here, you can see that uh, the first one is means long-term memory, that same data pass every unit. And second one is the short-term memory, sometimes it called the previous hidden state information. So the LTM pass all over the recurrent cell or unit, whatever you say, but short-term memory is just past the nearest one. And finally the it's continuous one. And if we clearly if you remind it that this previous slide you show that vanilla RNN only use one type of activation function. Here we can see that two type activation function, total four activation function used. And how do actually it update their weights, and also the long-term memory information. So what makes the LSTM architecture more better than RNN? Well, it has mainly divided each cell divided into three part. First one is input gate, second output gate, and third forget gate. So forget gate is nothing, which means that which information he should keep or which one he should ignore. And the input gate represent the current cell current timestamp input. And output gate, which is basically the forget and input summation of the total result that goes to output of this cell and the other cell input. So here you will also see a clear view of the forget gate, input gate, and output gate. The first one is forget gate, that was comes from the previous one. And the middle inside input gate, it has two activation, sigmoid and tanh, yeah, hyperparabolic tangent. And the next one is output gate, and you can see that the previous one t minus 1 current time step t, and the output is t plus 1. So timestamp, which means that at the time which segment data we pass here. So this all about the theory of LSTM. Feel free to ask if you have any question. We will go to the one node. Okay, so we already see the architecture. This is actually a uh, cell of LSTM. So What should I do here? Now we will see the how mathematically formula works here or how it works. So okay, so consider okay, wait 1 minute. What happened? I don't know why it is not working here. Okay, so consider this is our previous hidden state input, and this is our long memory or cell that was goes to basically this one keep the previous information. So why it need previous information collection? Well, consider an example like I said I show one picture to you, so you can easily describe to me easily describe it. If I ask again after 2 minutes, you can clearly describe what you see in the image. But if I ask almost 1 week or 1 month later, suppose, then you almost forget. So uh, because in our brain or work it works very short time, but in the long time if we do not uh, keep it, we are going to forget almost. So that's why here the cell ct1 which pass every cell or unit, which keep all the required information that is very important for the uh, that is make a relation between what does the next one. And we know that when the next one is predict, it always calculate the previous one output considered. So we get this output from this ct or ltm, long term memory. So in this sigmoid basically it has it is our xt. So it has a weight. um, this cell has weight, so two weight here. So I just wrote this like as it is forget gate, so for better understanding I put wf, weights of hidden layer, then weights of current. And there has we saw a activation function is sigmoid. And we know that there has a bias, so we mentioned it bf. So similarly all sigmoid is be fill up like this. So but the calculation is different, and over the time here also the weight different. First we saw that what does the output of this sigmoid. Well, so first of all this weight and this multiply. Do we know that how to multiply it? H, oh man, so h of f, h, then sum with the current input and current input weight. Okay, so sorry for the handwritten as I am try to write by mouse it. So this is the actual inside. And now we calculate calculate and sum all of this and then pass into the sigmoid. So consider this result is for get timestamp output. So this is pass here, and uh, here is ct1. So these two multiply. And if you look at this architecture clearly, you can see here that the combination of multiplication and positive, so that's make the LSTM more better than the vanilla RNN. So similarly, inside the input layer, it has divided two part. One is input gate, and another one called input node gate. So the performance here actually. Okay, if I'm not drawing this one, like, okay, if we consider this, now we consider this one, then it will be changed as like, this is our input gate. So here we just simply write, okay, wixbi. So the same, just h replaced with the sorry, the f replaced by I as it is input gate we consider, and the similarly 10h we find. So consider that we have same things will be find here. Just I just ignore the repeated calculation. The symbol is different. So first of all, what happened after we find the two output, like consider here. Okay, I clear this. Okay, so consider this output is like it, and this output is we will consider as a gt. So t for timestamp and I for just input, and as input is divided into two parts, so we just give name other. So here what happened, it's going to multiply and then just uh, just pass here, and we find here the uh, output is like where it is goes. Okay, ft is there. So ft multiplication with ct minus 1. Basically these same things happened all cell, just the similar. So you can easily guess now what will happen. This output and this sigmoid output also multiplication with this tangent value, and we know that that tangent range is 10h range is -1 to 1. Whenever we pass, like it returns the value between -1 and 1, and the sigmoid return value from 0 to 1. So basically the way this architectures inside mathematics work. And so now moving our next part, the how do we run a simple RNN on Google Vertex AI. First of all, we have to uh, visit or we have to go to the Google Cloud, and Google Cloud Console, where that was I created a project. So if we click the drop down button, we can see one thing I add here. We must add any credit card or payment card for Google Cloud when we first time activate our account. And in the compared to the Azure platform, as it gives us free approximately $200 without add any card. So if we add this Google Cloud for practice purpose, we must add this credit card here. And then after activated the account, you can see look like this, and you can create a project. And if I search here, like there are a lot of component and resources available. I do not go everywhere. I just need Vertex AI. So if I write here, I just click, so it goes to me there, and it shows me that we must enable recommended API. And here I just say that if we visit the model garden, we can see there are a lot of pre-trained model available. So our goal is we just use Google Enterprise here. So maybe you ask that if I do same thing about Google Collab, so why I why I am trying this? Uh, because if we try to this just a different flavor, but definitely there is a quite difference between free Google Colab and this Colab Enterprise. So okay, if we just click here, like what happened, Kulam Enterprise, then it can goes to here. So okay, I just step by step go. Okay, it takes few minutes due to network and the PC. Oh, okay. Well, so whenever we first enter the option, we see there are four where we can import or connect our notebook. So I just use the upload notebook, and from here, this is the just basic RNN code I am doing here. So I run this. Okay. So what you will see here, basically I am not use any data set here. I just use created one default that's which has the 100 samples, and the timestamp considered 10, and input dimension 1, output dimension 1. And you know that as the our task is regression, so basically in the finally it return a value, so one value. That's why the output dimension one. And using the numpy we create a data set. And here I just for target just shift one. So and then I just use the simple uh, sequential RNN model. First of all, we need a sequential, as we know that deep learning or neural network is work as sequential. So, uh, do you think that we should remember everything? The simple answer is no. There are documentation available. If you like to keras, just search here how to TensorFlow use this, and also you can visit the keras. So whenever we reach the official documentation, so here we can see that basically what things we can do or what we have to pass here. So we set some value none, some are boolean truth, and some set value like activation function 10h. So vanilla RNN, we know that the default activation function is 10h. So if we want to change here we can, but do if we do not pass anything, then it works default h1. So I just pass the 50 as the input dimensional, and here is the input size. Okay, sorry for that. 50, which means that the next layer output basically. And the dense number of dense, which means that I denoted here. And in the model compile as a optimizer, I just use Adam. And for loss calculation I focus on the MSC. And if we load this the model summary, we can see here as we pass there 50, and the 10 comes from these time steps. And as we pass here that time step and input dimension. So as that we add only one layer, so that's why as I already told you, that is the simple RNN. So later code we see the LSTM, which has several more than 3 or 4 layer. Wait a little. So in the model summary, we see that here is total param 2651. Among them, wow, all are trainable parameters, though it is very simple and the data only 100. So it trains all input. But whenever sometimes you can look at this output, you can see some value for non-trainable parameters, which means that this parameter are not trained during the train. And this is the similar of that we know that epochs and batch size, that's the different from machine learning. So we pass our data and the target as a machine can learn here. So if I predict, I calculate as a loss. Why I need to flatten here? As you know, the final output in the uh, in the neural network we must do flatten. If we look any ANN or CNN code, you see that in the last layer you had a flatten option, and after before flatten it has shape 10 into 100. After flatten it goes one a vector which is 1000 row, and finally we calculate the MSC value. So this is the our loss value of this model. So this is the very simple one. So now we look at this complex model one. So I do setup here. Okay, well, so here I use LSTM for an uh, stock price data. So I download the data from internet. So if we show the data that what actually is data has, though it has we can see that date, open, high, low, close, adjacent, close, and volume. Basically these things are common for any stock market prices. Date is very important, or as also as this rest of the features. And among them our here I am trying to the close. My goal, my target is close, and rest of the features. So sometimes we can see that someone work for open or high. We can do anything what we want to do. So the data shape is basically here quite a big, but not as much as big. And well here p value and adf test. What why do we do this? Well, the sequential data has one of the great problem that has white noise. So this is the statistical things, so I am not going here. I just say that like the data has white noise or not white noise, we can confirm by the p value, probability value. So the after we calculate the adf, we got the p value. If the p value is less than, then we can say that is the stationary. And stationary data also, as well as it has no white noise. So uh, how look like the data? Actually I where I print the close feature against the date, how much it is. So we can see that there are a quite fluctuation over the time. So what if there is no fluctuation, like initially it is goes increasing, or it is goes decreasing. So if it is goes decreasing or increasing, we can easily find the pattern. That's why there is the complex, uh, sometimes fluctuation, sometimes you can see that here is remain steady. So that's why we need any deep learning or machine learning model which can find the best uh, relationship. So as we are one try to by hand calculate to find the relationship between this date and close. Probably it is time consuming, as well as not a easy task, this one. So I just okay. So calculate here the any missing date had or not, as in the as I am told, as the dataset that consists only the working day, they never consider the weekend. So here, if I find the missing date, I see that this date are basically weekend date. And as we know that the sequential data, so I just fill up this later on the feed forward and back forward method. So feed forward, back forward, how it's work? Well, like uh, so consider this, there are more values. Okay, so I have here data 4 and here data just like 8, so two date missing. uh, Assume that these are the weekend, so they ignore in the data set initially. So for the feed forward method, I just fill up this by the previous one, and back forward method I just fill up one uh, by the next the date. So as it is, the sequence is maintained. Otherwise, if I plot like this, these two day are missing, just for simple understanding. Or so that's why I want to like the balance here. So that's why I forward fill up this date with this using two, okay, two method, fill forward and backward fill. Okay, after that, initially, if you recall, the data shape has merely 10,000, 9,000 something, but now 13,000. And if we print now, but there is not any magnificent changes here, we can see. But okay, so the challenging task one is that, okay, now I am as after fill the data, so I calculate again that how much the gap between, or there is any gap between 2 days, more than one gap between